Brett for organizing all this and Lex for being such a great moderator. And I hope you all enjoy learning about dissociative anesthetics, because I think that they are a class that is neglected in the psychedelic community to some extent, partially because they're an especially confusing class in terms of their history, in terms of their toxicity, in terms of their therapeutic potential. And it's hard. Turn it up? I don't know. Okay, I can't. Okay, all right. So the reason that we're giving this presentation is we just finished a comprehensive review of the history, pharmacology, and to a lesser extent, chemistry of arylcyclohexylamines. It was published in the journal Drug Testing and Analysis a couple weeks ago. And so we're in a good position to give an overview of this class, but feel free to interrupt at any point, because I do think that it's a little bit confusing and convoluted, and a lot of this stuff that we covered had never been written, either because it takes place in the distant past. These drugs first were synthesized around the 1920s, and then very recently as well. A lot of these newer drugs like diphenidine have not appeared in the scientific literature until this paper. And one more thing is, I know that this is a crowd of people that care a lot about plant-based psychedelics, and I think that there's a little bit of a stigma attached to the dissociatives simply because they are synthetic compounds that don't have a long history of shamanic or traditional use. And so as a culture, we're still trying to figure out what to make of these drugs. It's a confusing but fascinating class, and I will let my friend Jason, who co-authored the paper with me, go over the first generation of dissociatives that took place before the introduction of the internet.
Okay, thank you. Can you guys hear me? Okay. So first, I think it's relevant to talk about the term dissociative and where it originated. So the term was coined by a neuroscientist named Edward Domino, and it was coined in response to the observed clinical response of patients to the drug ketamine, which is a very common dissociative anesthetic. What he observed was that the patients, although fully anesthetized, still appeared to have some type of presence. And so what he said was they were dissociated from the sensory environment, and hence the term dissociative anesthetics. So most of these compounds bind to an ion channel that we talked about earlier, Clint, regarding the Nmda receptor. And so I'm going to get a little bit more into the pharmacology of those classifications. Also, Dennis asked the question about the Kappa opioid receptor agonists, and they are commonly classified as dissociatives in the literature, and this is sort of an ongoing debate. There is animal data, for example, drug discrimination studies, that suggest they should potentially be classified differently, but there is certainly some overlap, and it's certainly an area that requires further investigation. That said, this class has a rich medical and non-medical history. And so what are shown here are just some representative dissociative compounds that in these cases were used clinically or investigated clinically. So PCP, ketamine, taletamine, DXM or dextromethorphan, MK-1, memantine, and amantadine. So we're going to revisit several of these shortly. So as Hamilton said, this is a very complex class, and this is represented in many ways. Edward Domino wrote a paper recently called Taming the Ketamine Tiger, and it's sort of, how can we get the benefits out of these drugs for medical uses while kind of minimizing some of the issues that arise from their psychoactivity and some other things like their abuse potential. And so this was just a painting of that, which I think is a nice intro into the phenomenology. So we typically classify drugs by a number of ways. It could be their chemical class, their pharmacology, or their phenomenology. So in this case, the dissociatives are classified pharmacologically as NMDA receptor antagonists, but also they share a core phenomenological effect. So that effect is highly dose dependent and very complex. This was noticed almost immediately when the animal studies were done with phencyclidine, PCP. At low doses, you had stimulation, whereas at high doses, you had almost sedation, catatonic responses, and anesthetic induction. So they induce a rich number of cognitive effects, altered thought patterns, somewhat reminiscent of psychedelics, a trend towards more philosophical ideology, tangential thought. At higher doses, you can get, grandiose illusions, and, somewhat as true with classical psychedelics as well. They also have complex effects on mood, euphoria. They can induce mania and anxiety. But I would say the sort of richest area of their effects are their sensory effects. So they are hallucinogenic, and they affect a wide array of our sensory perceptions. So somatosensory, a lot of people compare the effects of dissociatives to nitrous oxide and ethanol, especially at low doses, both of which do bind to the NMDA receptor and at least partially exert their subjective effects through that pathway. Auditory hallucinations are common. Visual hallucinations are very common, ranging from simple illusions and distortions of sensory visual perception all the way to complex open eye and closed eye generative imagery. Synesthesia has been reported in the literature with ketamine, DXM, and PCP, which is very interesting. A fusion emerging of sensory phenomena. Also, I think it's relevant to bring up, there was a recent study done by Reisig et al. And they found that not only, they studied the dose response of dextromethorphan in patients, and they reported mystical experiences in the patients. Also, the subjects experienced effects that they believed were similar to classic hallucinogens like psilocybin. Okay. So I think it's important to point out that they have some similarities with classical hallucinogens. This is the NMDA receptor. It's a ligand and voltage-gated channel. So it's actually a tetramer. What's shown here is only 2 subunits. So there's, I touched on a little bit earlier with the NR2 and NR1, there's a whole range of subunits that can be combined in many different ways to give rise to a number of functional NMDA receptors. Now, NR2A is one of the more expressed of the subunits, and but that said, the dissociatives do bind to all of the different subunits, and the selectivity is only beginning to be studied, and we don't know yet what role the different subunits play in the functional receptors. There's a number of binding sites on this receptor. So what's important though is the glutamate and glycine binding sites, which are the competitive agonist sites. So those must bind for the channel to open. There's an additional requirement, and that is that the cell, electrochemical potential of the cell has to be depolarized for the channel to functionally open and operate. If those criteria are met, the channel opens and sodium and calcium can flow into the cell and activate a whole range of physiological responses. The drugs we're going to be talking about bind inside the activated channel, represented by the PCP site, so that triangle site inside the channel. And they physically occlude the ability of ions to move through the channel, so they're antagonists. This is a heat map showing the binding of several different PCP derivatives in CNS-relevant receptor sites. So you can see they all bind to the Nmda receptor. So if it's red, it means high affinity. As it moves towards green, it's lower to non-significant binding affinity. In addition, you can see they're non-selective, all right? This is true of a lot of drugs. The Nmda receptor affinity is particularly important to the pharmacology of these agents. Other receptors do not seem to correlate nearly as well. That said, within an individual compound, they may modulate its activity and give rise to unique phenomenological or pharmacological effects. And then what's shown here is the correlation between affinity for the Nmda receptor and the dose needed to induce dissociative effects and hallucinations in humans. And you can see, this is preliminary, but there is a reasonable correlation. And this is just considering binding. It excludes any type of pharmacokinetic factors that would alter things like a drug absorption, half-life, that complicate the matter a bit more. So PCP is sort of the grandfather of this dissociative class. As Hamilton said, there were drugs that we now know to be dissociatives discovered earlier than PCP. However, it was the discovery of PCP that really opened and birthed this field because it was fully pharmacologically characterized and the potential of the class was realized. So PCP was discovered by a Parke-Davis chemist on March 26, 1956. His name was Victor Maddox, and it was actually a serendipitous discovery. He was trying to make a different compound. Fortunately, instead of saying, oh crap, the reaction didn't work, and tossing it like many chemists would do, he said, well, it didn't work, but what happened? And when he characterized the outcome of the reaction, he found this new compound had formed, which was PCP. He realized it was an interesting structure, and he submitted it for preclinical studies in animals. And they immediately observed that it had a lot of unique potential, particularly as an analgesic and anesthetic agent. So it's really interesting. So it was discovered in 1956. In 1957, it was already being given to humans in clinical studies. Today, that could never happen. I mean, we're talking 10, 20 years and billions of dollars, $1 billion at least to develop a drug. So it's really impressive how different things were back then. These are the first clinical study was done at the Detroit Receiving Hospital with Parke-Davis collaborators. And this is the actual paper published in 1958. And they confirmed the results in animals that it was an effective anesthetic and analgesic agent. They noted a phenomenon that they called emergence delirium, which was when the patients woke up, they exhibited psychoactive effects, hallucinations, paranoia, catatonia. And so they kind of downplayed it. But at the same time, other authors and people who experimented with PCP began to note it more. And there was a desire to develop derivatives that might have less of that potential. So this work led to a Parke-Davis consultant named Calvin Stevens discovering a class of compounds that ultimately led to the discovery of ketamine, which is a close chemical cousin of PCP. What was unique about ketamine was its short duration of action, which they logically reasoned would have less emergence phenomena and be a better anesthetic. And so they tested the drug in humans. That work was done by Edward Domino in 1964, actually in 20 prisoners, another thing that is not done today. But the drug was a very effective anesthetic. They observed less emergence delirium than with PCP, and so they were very optimistic. They were also very careful how they worded the results of the study, and again downplayed some of the similarities to PCP because they didn't want that negative connotation. And so by the time ketamine was released, PCP was removed from its approval for experimental use by the FDA at the behest of Park Davis. So they removed it and started marketing ketamine as Ketalar. So very shortly after the therapeutic use was the non-medical use of PCP. So the first examples or documented appearance of PCP we could find were around the late 1960s in San Francisco, but other authors have concluded that it appeared in a number of US cities around this era. At first, it was sold typically as a drug of deception, and this is what led to a lot of the negative effects, potentially, that resulted in users not really taking to PCP. So it was commonly sold as mescaline, for example. So a lot of people who thought they took mescaline in the late 60s were actually taking either PCP or PCP mixed with LSD. So not only was it responsible for a lot of the negative effects associated with PCP, but maybe people freaking out on mescaline as well. It didn't really get popular until the mid to late 70s, when people, instead of taking it as capsules and as drugs of deception, it developed its own culture. And people began actually either snorting it or smoking it. And they sort of had a better control. They knew what they were taking to some extent, and they were able to titrate the dose a little bit better. Around this time, though, the media sort of grabbed hold to the growing trend, and there was a lot of sensationalism. I mean, stuff that makes reefer madness seem very amateur. So we'll see that we found some really great old publications that were geared towards law enforcement and lawyers on how to handle what they would call PCPers. In some cases, they were selling nets to capture PCPers. They were extremely paranoid that these people were like Incredible Hulks. You know, like there's reports of people taking multiple gunshots and then still beating up cops. They claimed that they were able to rip handcuffs. We even found a picture of one of the supposed handcuffs that had been ripped by a PCPer. And my personal favorite is that PCPers have even been known to pull the doors off patrol cars. So, you know, it's not that there was no truth to some of these sensational stories. I mean, I'm sure you've all heard, there are some crazy examples of people overdosing on PCP and becoming violent and dangerous, as there are with other drugs. But the overall conclusion is that these were greatly sensationalized by the media. And it played in, lawyers too would take advantage of it and try to claim that their defendant was intoxicated on PCP and therefore wasn't responsible. So it became sort of like a cultural, complex phenomenon. Ketamine was not nearly as popular as PCP. So it first appeared just like PCP in the late 60s, again sold as a drug of deception, in this case mescaline or potentially a cannabis type drug. And the first scientific or literature reference to ketamine's psychedelic or psychoactive effects were in a New England Journal a letter to the New England Journal of Medicine. But it wasn't really until the 1990s that the popularity of ketamine grew. This is probably because of the fact that the illicit ketamine or street ketamine was almost always diverted. Clandestine labs did not pop up, and that's likely due to the greater difficulty of producing ketamine clandestinely than phencyclidine or PCP analogs, as we'll see here in a second. But over the years, there were some interesting publications on ketamine. Marcia Moore's and her husband's Journeys into the Bright World, and John Lilly's The Scientist. There was also a High Times article on avant-garde highs, and they listed ketamine as one of them. Also, the comic book Fabulous Furry Freak Brothers had a little comic on the effects of ketamine. So, what you see here is the PCP analogs or derivatives that have appeared on the streets from the late 1960s up until the 1990s. After the 1990s, they seem to have virtually disappeared from the street. As we'll see, it's sort of, they were sort of surpassed by internet distribution of dissociatives, and Hamilton's going to go into that here in a second. There's a lot, we found that a lot of people were claiming that there were 30 or more illicit PCP derivatives that were sold on the street, and again, there was a lot of sensationalism going on. The truth was, you know, there was only, we could only find reference to these 13 compounds, I think my math's right there, but around that, that were actually documented. So only 3 of these became significant. That is, they were distributed in multiple states in sort of large quantities. Those were TCP, which is the thiophene derivative, PCE, which is the N-ethyl derivative, and PCPY. And they got a lot of, those compounds got a lot of media attention them that are rather interesting. But as you can see, these are all really simple derivatives of PCP, just modifying certain functional groups out of one of the 3 regions that can be modified. Now, one other thing I wanted to say is, you know, these are commonly called designer drugs. And the media sort of portrays it as clandestine chemists were designing these compounds in their basements. Well, it turns out that only one of these compounds did not exist in the scientific literature prior to its appearance on the street. So what was going on really is clandestine chemists were accessing the scientific literature or accessing someone with knowledge of it and using that information to synthesize compounds that they knew would have some activity. They weren't just blindly experimenting in their basements, at least in the case of the dissociatives. So this is the last thing I'll do. This is just showing some of the different synthetic routes to the arylcyclohexylamines. The most common one used for PCP production happens to be the same one that Maddox used in the discovery of PCP, and that's this PCC route. But they can be made from a number of other routes as well. And Hamilton will show a slide shortly that shows a synthesis of PCP via the PCC route that's actually called the bucket method. And this is actually it's in the literature, but it's a transcript of an actual clandestine lab operator's notebook where he was producing large batches of PCP literally in plastic buckets. So the synthesis can be fairly easy. You don't always end up with a good product, but it's potent enough that it didn't really matter. All right.
So when you look at the first generation of clandestine chemists that were making these PCP derivatives, their motivations were slightly different, and the restrictions that controlled what they made and how they made it were different as well. One thing is that they were not selling most of these compounds as what they truly were. They were selling them as THC or mescaline or things like that, and so it didn't really matter what the actual chemical was as long as it was psychoactive. And often when they would make some sort of modification like the ones that were shown on the previous slide, it was because it allowed them to bypass a watched chemical like piperidine, which was the primary watched chemical that could be substituted with various other things. So that really changed in a huge way around 1999 when an internet clandestine synthesis community started to emerge. And this, I think, represents the biggest change that took place since Park Davis did its first research on PCP and related compounds. It was The Hive, which is a website that was run by a chemist in Texas named Hobart Hewson, and it was sort of a meeting place for chemists. It was a very diverse crowd. It was a sort of melting pot. You had people that represented the old world who, you know, buying piperidine in gas cans and synthesizing PCP in a garage, and you also had people that clearly had a very sophisticated understanding of organic synthesis and access to all sorts of analytical equipment. here you can see this sort of synthesizing TCP in what is clearly a bathroom with a soap dish and disposable razor in the bottom left corner. But so it's this juxtaposition of very sophisticated scientific research done with very primitive equipment or laboratories. But during this period in the late 90s and early 2000s, a lot of very important research was done, and it allowed people to share what they'd learned about these PCP derivatives for reasons other than just circumventing the laws that allowed them to make some kind of dissociative compound without purchasing piperidine. And one of the most important people on the Hive was a chemist who used the pseudonym HMS Beagle, which is named after the boat that Darwin was on when he was exploring the Galapagos. And he actually, I guess appropriately, had a crucial role in the evolution of the new dissociative anesthetic world. And what he did, he authored an enormous review of dissociatives, but also he detailed his personal experimentation with a few drugs that were unknown at the time. Even though they existed in the scientific literature, nothing existed on the qualitative effects. So he was doing a sort of Shulgin type research, you could say, synthesizing the chemical, characterizing it, and releasing the information so other people could learn. That was something that couldn't have been done in the past. And when you look, it's you know, right now we've internalized the stigma associated with dissociatives to such a degree that it's almost impossible to imagine that these are drugs people would have wanted at one point, that they would have willingly purchased some of these things. But in 1977, more PCP labs were busted than any other type of drug, more than methamphetamine, more than LSD. That was the #1 drug that was being produced in clandestine labs, according to the DEA, which is kind of hard to believe. And there was, before that, there was quite a bit of research on the psychotherapeutic value of them as well, which again sounds ridiculous. PCP psychotherapy. It's almost, it seems barely conceivable now, but that was a mainstream medical area of inquiry. So on one hand, you had this bridging of the old world of clandestine synthesis, but you also had a new market emerging to sell drugs over the internet as well, not just dissemination of information about chemistry, but to sell the drugs themselves. And that started out somewhat slowly with drugs that already had pre-established medical and scientific utility, like DXM, which is a widely used cough suppressant, or ketamine, which was not a controlled substance in the US until 1999, which many people forget, as well as, to a far lesser extent, MK801, which is one of the most potent dissociative anesthetics known and is used almost exclusively in scientific research, but did become available as a research chemical used by humans for a brief period in the early 2000s and resulted in one fatality. So here's just a screenshot of one of these early DXM websites, and this really represents the beginning of the research chemical scene, which has become a very important industry in recent years. There was no innovation, nothing was created specifically, it was just reselling bulk quantities of DXM that were manufactured in China and India. But it was profitable enough that this was getting coverage in the New York Times, in the mainstream media, and it was, even though DXM is a pretty forgiving compound when used reasonably, like all drugs, if you use it in a completely reckless manner, it will kill you. So you know, there were some problems associated with that, and especially because it was being sold at prices as low as $1 a gram. Maybe not from this particular vendor, but it did get that low. So people suddenly had access to enormous quantities of drugs directly from the manufacturer, almost, and didn't always behave in the most responsible manner. And this is just to show you the difference between the old world, where people are passing down these handwritten notes that describe the synthesis, to this new world where you have labs in China where you can just send them a diagram of the chemical that you want and they'll manufacture it for you. But that started happening in the early 2000s with psychedelic tryptamines and phenethylamines and some stimulants. But there was still some hesitation with the dissociatives, because of the same stigma, their association with cannibalism and insanity and murder and death and all these negative things. I think a lot of the people that were in positions of power in the research chemical industry didn't want to have dissociatives on the market. They thought that if these drugs were introduced, it would be disastrous. But that eventually changed in December 2008. There was an English research chemical vendor, now defunct, called Nmda, that decided to sell 4-methoxy-PCP, which is a drug that was first tested by HMS Beagle. And what happened was interesting simply because nothing really happened. No one went crazy, no one ate their friends, there were no deaths, nothing of note happened. People used the drug somewhat responsibly, they enjoyed the drug, they bought the drug, and it proved that these substances aren't inherently psychotomimetic. They don't 100% of the time result in these really negative dramatic reactions. And so, of course, it just kept going. After 4-MeO-PCP, then people started to wonder about 3-MeO-PCP. What might that do? And these dissociatives started to roll out of the Chinese labs. The next one was methoxetamine, which some of you may be familiar with. Or not, I don't know. Okay, some of you are. And the story behind methoxetamine is especially interesting because that is, we talked earlier about designer drugs, that most of the things that are classified as designer drugs are not truly designer drugs unless you consider the pharmaceutical companies the designers, which is also a testament to their perceived medical utility. These things are in patents generally as neuroprotective drugs, but then at the same time they're going to be in the mainstream media as neurotoxins and cannibalism-inducing agents. But so the first drug that was rationally designed, it was methoxetamine. It was designed by a chemist in the UK who had lost his hand in a bombing and suffered from crippling phantom limb pain. And he'd spent most of his adult life looking for a chemical that could allow him to function without feeling pain. And he found that cannabinoids and dissociatives were the two classes that could restore his body image in such a way that he no longer felt this pain. And so he felt that methoxetamine had an enormous therapeutic potential, and he collaborated with a research chemical vendor, brought it to the market. Again, it was very successful. There were no disastrous responses right off the bat, and these things just kept snowballing in popularity. There were some, here's an analysis published by DanceSafe of 4-methoxy-PCP, where they called it the dirtiest research chemical they'd ever seen in 15 years of watching analysis of gray market and black market chemicals, so that's not encouraging. But for the most part, this went off without any major problems. And as is the case with so many of these things, it's the media that constructs a problem, not any sort of inherent property of the chemical itself. Suddenly, reports started to emerge in various English publications about this methoxetamine causing fecal incontinence. That was one of the main accusations associated with the drug. But there were a number of different ridiculous claims made, and it just kept snowballing in the media. There was another vendor that decided to call it Rafflecopter for some reason, and just to show you how savvy these vendors are, when this first appeared on the market, it started getting a huge amount of press coverage. And as I generally do, I emailed the company to ask them, what's going on with this? Why are you doing this? And their response was, we already have an article about ourselves that we've pre-written and we want to sell it to you to publicize our own product, which I thought was mind-boggling and is truly emblematic of our current age, that the dealer has a press kit that is pre-assembled to publicize their product. And so, yes, people start talking about it. You assign a ridiculous name, a ridiculous side effect, and the inevitable result, you give it some special packaging. They decided to call methoxetamine Special K, which is especially confusing because that's already a nickname associated with ketamine. But yeah, there's branding. You could buy this in stores in the UK, pressed into tablets. It really became a phenomenon because of differences in the laws in the UK versus the US, where you have this analog act that makes everything ambiguously legal or illegal. But then methoxetamine was placed under a temporary ban, and again, this just shows that once a market is established, once something gets its foot in the door, it becomes very, very hard to extinguish. Dissociatives are, especially PCP, it's an American phenomenon. PCP does not exist elsewhere. It was discovered in the US, it was used primarily in the US. The UK didn't have a PCP scene, neither did Germany, neither really did anywhere. But then ketamine was used internationally, of course, but PCP wasn't. Suddenly, once people recognize that these dissociatives are actually attractive compounds to use recreationally, there's nothing you can do to stop it. And so then after methoxetamine was controlled, then N-ethyl ketamine came out, 2-methoxydeschloroketamine, and a number of others. And the response was to do a blanket ban on all arylcyclohexylamines in the UK. And they thought that this would actually solve the problem. It never does. And within 2 weeks, I found this especially impressive, 2 weeks after the ban, which was worded in such a way as to prohibit virtually all conceivable PCP derivatives, someone had already synthesized and tested and started to sell an alternative compound called diphenidine, which circumvented the ban and seemed to be a reasonably effective dissociative as well. And that's still being used and is now associated with some health problems. Here we have a timeline that might be a little complicated to read in this projection, but it's part of the drug testing and analysis paper, and it gives you this idea where you can see in blue you have medical use, and you can see how many of these compounds start medically and then gradually transition into non-medical and then illicit use once people decide it's necessary to make them controlled substances. And so that pretty much concludes it. Here, I just wanted to say a little bit towards the end that, this is an especially complicated class. It's not like serotonergic psychedelics where you can do a certain amount of reading and come to a relatively informed conclusion that they are reasonably safe, that they probably have psychotherapeutic benefits and would be useful medically. With the dissociatives, there's no question that they help people with use as analgesics, use in anesthesia, use as antidepressants. But if you look at their track record as well, they also have been associated with a lot of problems. There's an ongoing debate about Olney's lesions that some of you may be familiar with, that it remains inconclusive, mostly because there hasn't been experimentation done in human, well, you can't do it in humans, but in higher, in primates. And here is just a few possible routes that I predict may be used in the future. 2-MDP has already been tested. That's something that's already been written about on forums like Blue Light, and some of these other ones are just things that you may see in the next few years. It's hard to say. But like I was saying earlier, once the market is established, it really can't be extinguished very easily, and all attempts to prohibit these compounds have only resulted in new ones coming out at an astonishing rate. And I guess a final cautionary note, just to go on, is there, it seems that whenever one of these drugs is prohibited, also there are these amazing physical health problems that become associated with them as well, in addition to addiction and things like that. It's just a strange synchronicity that ketamine had been used for 30 years medically without any problems, any sort of urotoxicity associated with it. And then as soon as it became a controlled substance, these reports started to emerge in the medical literature of both kidney and bladder damage that is really frighteningly severe in a huge number of users. And no one knows why this happens, but I think that one possible explanation, and I'm not certain this is the case, but one is that when you control a substance, when you prohibit it, it pushes it into the gray market, there's no regulation, and it's possible that some of these emerging batches have some sort of contamination, although there's also arguments to the contrary, so I won't necessarily say that's the case. But yeah, that's it. Does anyone have questions?